Hello everyone, today we're going to talk about compound inequalities, which is essentially just combining inequalities and doing two at the same time. So kind of like how we started with linear equations, then we got into systems of equations, we're kind of do inequalities and then compound inequalities. So the first thing we're going to talk about is the intersection of two sets. The intersection of two sets is essentially just the spots that they have in common. It's like the intersection of two roads. It's the points in which they share the same part. So some examples of compound inequalities would be something like x minus 3 is less than 5 and 2x plus 4 is less than 14. So that tells you two different things about x, right? And then similarly, we have something like 3x minus 5 is less than 13 or 5x plus 2 is greater than negative 3. So these words and or tell us two different things about these variables. They essentially give us two different options. So and will tell you we're talking about an intersection or response to union. This is going to be the fancy way we write this. I'm not really going to worry too much about it. Just note that this little ring right here means intersection. That means it's the spots that they have in common. So for example, this may not look familiar right away, but I promise you we did this really early in the semester. So try to think back, looking through your notes. These are set builder notation, okay? So this is a set. This is the intersection of another set. So for part A, what it's asking for is what do these two sets have in common? So essentially, I want you to look inside these sets and tell me what they share. What do they have in common? What intersects? We have 1, 3, 5, 7, 2, 4, 6, 8, 10. Do they have anything in common? No. So the solution is nothing. It's the empty set. So let's look at B. Does B have anything in common? We have the intersection of two sets. We have 1, 3, 7, 2, 3, 8. Yeah, they've got the 3. So that means the only thing they have in common, the only thing in the intersection is 3. Let's try this one. We have 3, 4, 5, 6, 7, and 3, 7, 8, 9. What would they have in common? We've got a 3 in both of them, not a 4, not a 5, not a 6, but we do have a 7 in common. So the intersection of this one would be 3 and 7. So let's look at some compound inequalities involving and. This is our intersection. What we're going to do if we have an and problem is essentially we're going to solve each inequality separately, and then we're going to find out the intersection. We're going to find out what they have in common. So for this problem, basically we're going to try to graph these. They're usually more helpful if we graph them or if we do them in that parenthesis notation. So let's take a look at these. We have x is less than 3 and x is greater than or equal to negative 1. So if we graph both of these, if we graph where x is less than 3 and then we graph where x is greater than or equal to negative 1, the only thing in our solution set is the stuff that makes both of these true. This is like saying, I'm not sure how much money I have in my account, but I know that it's less than $1,000 and it's more than $500. So could I have 1,500 in my account? No, because it's more than 1,000. Could I have nothing in my account? No, because it's greater than 500. So that means your answer is somewhere within those two parentheses, two boundaries. So what's true for this one? We have x is less than 3 and x is greater than or equal to negative 1. What's the part where they intersect? So it means x is greater than or equal to negative 1 and it's less than 3. So your solution set is everything in between those two. It's the part where they overlap. So let's try this one. This time we have to do a little work to find out what x equals, right? So the first thing we have to do is simplify both inequalities. The first one we have x minus 4 is less than or equal to 2. So for this one, all we have to do is add 4 to the other side, and we get that x is less than or equal to 6. Then we have our second set, which is 3x plus 1 is greater than negative 8. For this one, we're going to add or subtract our 1 over, then divide both sides by 3. We get that x is greater than negative 3. So now using both of our solutions, we have that x is less than or equal to 6 and x is greater than negative 3. So if we graph x is less than or equal to 6, we go all the way up to 6 and we graph everything that's less than it. And then we have the x is greater than negative 3, so we go all the way back to negative 3, and then we go to the right. Now we just take what overlaps. So basically we're cutting out everything that's below negative 3 and everything that's above 6. So it gives you that your solution set is negative 3 up to positive 6. Now this one looks a little bit different, right? Because we don't have that word and in there. Basically this is saying the same thing. This is giving you two problems in one. This is saying 3 is less than or equal to 4x minus 3, which is less than 19. Okay, this is an and problem, even though it doesn't look like it, because it's giving you two sets of parameters for this x. It's telling you that this 4x minus 3, it's telling you that it's bigger than 3 and it's less than 19. So we're going to solve this separately. We're going to separate these into two problems. We're going to do 3 is less than or equal to 4x minus 3, and we're going to do 4x minus 3 is less than 19. So we're kind of just duplicated the middle and separated it. Then from there, we just solve each one. I'm going to add 3 to this side. I'm going to add 3 to this side. Then all we have to do is divide by 4, divide by 4. So we get 6 divided by 4 is 1.5. 22 divided by 4 is 5.5. So that gives you your parameters. It tells you that x is greater than or equal to 1.5 and x is less than 5.5. Graph those two and take where they overlap. So it tells you that x is going to be greater than 1.5 but less than 5.5. So your solution is 1.5 all the way up to 5.5. So another one. Then this time we're going to graph each inequality and we're going to see what happens. So in this case, we have x plus 2 is less than 5 and 2x minus 4 is less than negative 2. So to solve the first one, we're going to subtract the 2 from both sides and get x is less than 3. And on the right, we're going to add the 4 to both sides. We get 2x is less than 2. Divide both sides by 2, and we get that x is less than 1. Now we graph each of them. We'll graph x is less than 3. We're going to graph x is less than 1. Why does this one look different? Well, it looks different because they're not facing the same direction, right? We're not getting something in the middle. But do it the same way. Just graph what they have in common. And what they have in common is everything from here to the left over. Basically, what this is saying is we're going to lose out on this 1 to 3 bit because this is not part of the solution. It's not part of the and. So your answer is really just negative all the way up to 1. Let's try this one. Let's see what happens. We have 4x minus 5 is greater than 7 and 5x minus 2 is less than 3. Solve each of them. We're going to solve the one on the left by adding 5, then dividing by 4, so it says x is greater than 3. Then over here, we're going to add 2, divide by 5, so it says that x is less than 1. So let's graph each of them. We're graphing x is greater than 3, and x is less than 1. And now because this is an and problem, and we're looking at the intersection, we have to ask, what do these two have in common? Well, nothing. Your solution is the empty set. These don't have anything in common. If you try to overlap them, nothing happens. So your solution for this one is nothing. You'd say no solution. There's no number that makes this true. How about this one? In this case, we're going to try to do this a different way, okay? The last time we saw one of these where we have two sets of inequalities in one problem, we tried separating it, but this is your other option. You can do it all at one time as long as you remember that whatever you do to one side, you have to do to all the sides. So in this case, if I'm trying to get this 3 away, because I have this 2x plus 3 in here, I'm going to subtract this 3 in the middle, but I have to remember to subtract the 3 from both sides too. So we subtract the 3 from both sides, we get negative 2 is less than or equal to 2x, which is less than 8. We divide everything by 2, and it gives us negative 1 is less than or equal to x, which is less than 4. So that gives us a solution set of negative 1 all the way up to 4. So now we can talk about the union of two sets. And the union of two sets is going to be similar, but it's going to be kind of the opposite. So the intersection is the stuff that they have in common. The union is the stuff that's in true for either one of them. So it's the combination of them. So let's look at the union of these. The union just says combine them. So basically, if I'm taking the union of two sets, I'm just going to take the bigger set and plug in everything it's missing. So for this case, we have 1, 3, 7, 8. And for the union, I'm going to try to combine them. So I'm going to take everything that the second set has that the first one doesn't and put them in. So does the first set have a 2? No, so put the 2 in. Does the first set have a 3? Yeah, it does, so we don't have to worry about it. And the first set also has an 8. So your solution is just plugging in that 2 to the first solution. That's the union, that's the combination. Let's do the union for this problem. I'm going to take my bigger set and leave it, and then plug in everything the smaller set has. So one has 3, they both have a 3, so don't worry about it. This one has a 7, that one also has a 7, so don't worry about it. But then we have an 8 and a 9, and this first set does not have an 8 or a 9, so just plug them into it. So your solution for the union, or the combination, is 3, 4, 5, 6, 7, 8, 9. So now let's look at some compound inequalities involving or. So this is something that makes it true. This is like saying, well, I don't know if I got paid today, so I either have less than $500, or I have more than $1,500 because I don't know if I got paid yet or not. So this is giving you two separate options for what your answers could be. So the way we're going to do this is solve each inequality separately and then draw the combination, or when you put it all together. So let's look at these. We have 2x minus 5 is less than or equal to negative 11, or 5x plus 1 is greater than or equal to 6. So it's going to give us two different options for x. So let's solve this one on the left here. We're going to add our 5 over, divide by 2, so it gives us x is less than or equal to negative 3, or we're going to subtract our 1, divide by 5, or x is greater than or equal to negative 1. So now we just graph either. We have that x is less than or equal to negative 3, or x is greater than or equal to 1. Gives us two solutions. So in this case, our solution set is made up of two distinct intervals. It's negative infinity all the way up to 3, combined with 1 all the way to infinity. So that's your solution right here. Or you could just give me this. So let's look at this problem. Parts for an automobile repair cost $175. The mechanic charges $34 per hour. If you receive an estimate for at least $226 and at most $294 for fixing the car, we want to know the time interval for the hours that the mechanic will be working on the job. So this is an OR case. So in this case, we don't know what the number of hours is, so that's your variable. X is the number of hours. Now we want to set up an inequality. So we know that the cost of repairing the car is the price of the parts, 175, plus the cost of labor, X, times the amount, so that's going to be 34 per hour. So then we know the cost to repair the car is going to be 174 or 175 plus 34x. But now we know that it's going to be between these two variables. We don't know, it's either going to be as low as 226 or as high as 294. So from here, all we have to do is subtract your 175 from both sides, divide both by 34, and you get that 1.5 is less than or equal to x, which is less than or equal to 3.5. So this guy is saying that this repair could take anywhere between 1.5 hours or 3.5 hours. So that's an easy example of where it could run into. Let's try another OR problem. We would use the graphs, right? So we have 3x minus 5 is less than or equal to negative 2, or 10 is less than, or 10 minus 2x is less than 4. So in this case, we want to solve each of them separately, graph their intervals, and see what they have, not even what they have in common because it's an OR problem, so just combine them, right? So we have 3x minus 5 is less than or equal to negative 2. In order to solve this one, we're going to add 5 to both sides, then divide both by 3, and you get that x is less than or equal to negative 1. Or in this case, we can subtract the 10 over, divide by negative 2, but remember when we divide by that negative 2, your interval switches. We're going to flip that inequality sign. So we get that x is also greater than 3. So in this case, we have two different graphs. We're going to graph x is less than or equal to negative 1, and we're going to graph that x is greater than 3. And you just combine what they have in common, or just combine everything, right? This doesn't have to be in common because it's an OR problem. So your solution says just negative from infinity all the way up to 1, and then 3 all the way to infinity. Let's try this one. We have 2x plus 5 is less than or equal to, greater than or equal to 3, or 2x plus 3 is less than 3. Solve each of them separately. We're going to add 5 or subtract 5 from both sides, divide both sides by 2. In this case, we're going to subtract 3 from both sides, divide by 2. So we get that x is greater than or equal to negative 1, or x is less than 0. So graph each of them, and look what happens in this one. When we graph each of them, we have x is greater than or equal to negative 1, and x is less than 0. So look what they have in common. Everything, right? They overlap completely. So that's like saying you have all real numbers as your solution set. You can plug anything in it, it's going to work. Okay, so that's the end of section 4.2. Continue to be sending me your work and your homework. I can't grade it if I don't get it. But again, as long as you're turning me into your work, I don't want you to worry about your grade. Everybody who turns everything in will be in a just fine spot come towards the end of the semester, which we are winding down on. We're pretty close to ending up with section 4. I think there are only 2 more sections, and then we can deliver our final exam. So please make sure everything's into me. Our final exam or our final grades are due pretty early this semester, so I'd like to get them in as soon as I can. So please be sending everything in, and keep yourselves happy and healthy while you can. And we'll talk again soon.